Number 6. The function f is twice differentiable. The table gives values of f and its derivative f prime at select values of x. Part A. Find the limit as x approaches 2 of f of x over x, or state that the limit does not exist. So to find this limit, what we'll do is we'll break this up and find the limit as x approaches 2 of f of x divided by the limit as x approaches 2 of x. Now I think what they're looking for here is they want you to make the connection that because this function is differentiable, it's continuous. And so because it's continuous, that means that this limit equals f of 2. Now this limit on the bottom is pretty straightforward. X is continuous. As x approaches 2, this approaches 2. Now when we consult our table, f of 2 is equal to 3. And that is the value of our limit. Now part B, now they define this function, g of x is f of x. So to find g prime of 2, we're going to have to find g prime of x, which is going to require us to use chain rule. So we take the derivative of the outside times the derivative of the inside. So next, we'll substitute in 2 in for x. So f prime of f of 2 times f prime of 2. So first, f of 2 is 3. So we have f prime of 3 times f prime of 2. So f prime of 3 is equal to 9. F prime of 2 is equal to 4, and that gives us 36. Part C. Let h be a differentiable function such that h of 0 equals 10, h prime of x equals f prime of 3x. So we want to find h of 2. Show the work that leads to your answer. Now we've seen these types of questions before where we want to know a function value and they give us another function value. That's the fundamental theorem of calculus right there. So, h prime of x. So the integral from 0 to 2 of h prime of x dx equals h of 2 minus h of 0. So that gives us our value for h of 0. The problem is we don't have anything to handle this integral because this is in the non-calculator portion. But what we can do is we can make a substitution and substitute in f prime of 3x because that's equal to h prime. Now I'm going to take out h of 0 and put 10 because we know that's the given value. So here what we have to do is we have to take the antiderivative. That's going to be f of 3x. But remember, because we do u substitution, that's chain rule backwards, we're going to end up dividing by 3. So that's h of 2 minus 10. Now, when we plug in 2, we have f of 6 over 3 minus f of 0 over 3. And I'm just going to evaluate these. F of 6 is 5 over 3 minus f of 0 is negative 1 over 3. So that's going to equal 6 over 3, which equals 2. Now all of that equals what we said was equal to h of 2 minus 10. So 12 is what h of 2 is equal to. Part D. Let k be the function defined by k equals the integral from 0 to x of t squared times f of t dt. So for part 1, find k prime. So this is the second fundamental theorem of calculus. So when we take the derivative, we substitute this in place of t, but then we also multiply by the derivative. Now thankfully this is just x. So k prime of x is equal to x squared times f of x. But for Part 2, we want to find k double prime. That means we have to find the derivative of what we just found. So k double prime, and this is going to require us to use product rule. 2x times f of x plus x squared times f prime of x. So k double prime of 3, that's going to equal 2 times 3 times f of 3 plus 3 squared times f prime of 3. So 2 times 3 is 6 times f of 3, that equals 9. And then 3 squared, that is 9. Times f prime of 3. Whoops, f prime of 3 is 9. F of 3 is equal to 8. There we go. So that's 48 plus 81. So added together, we get 129 is our value for k double prime of 3. And we'll label that just for good measure, positive 3.